Okay, so the recording is also started. So in the last class, we talked about the history of the blockchain, where it started, and we talked about the challenges involved in the centralized infrastructure model, mainly in the existing banking infrastructure. What are the challenges? Because most of the networks are built on centralized infrastructure models, and considering this, solving this, how blockchain architecture will solve the problems. Okay, solves the problem of the centralized infrastructure. We discussed about the main points, how it is solving the problems of centralized, like the scalability, the point of failure, right? And we have the transaction fee and the complete control of your account in a centralized network. How these problems are well addressed in blockchain is by using the concept of a decentralized distributed ledger, and they use the cryptographic algorithms. We have the consensus mechanism and the features like immutability and P2P communication, and the database which is based on NoSQL database. So all these concepts will come as a part of your blockchain package. Okay, so these are the points we discussed in the last session, and we talked about the use cases. And in a if you want to update a card in a blockchain network, how we can track a specific an asset. So in this case, a car which can be tracked in a blockchain. And if you without the blockchain, what are the challenges? You have a lot of challenges in make sure is it the right ownership, or the car is exactly built by that specific manufacturer or not, the insurance details of the car. So these are all the challenges we have it in the present, and how these challenges will be solved when we move on to blockchain, and how using this DLT technology, how we are going to track those details in a very transparent way and with accountability and with a lot of security. We talked about all these points in the last class, right? So that gives, it's not only a specific example of the car. Instead of car, you can replace the car with a house, a property. It can be a diamond. You want to track a diamond as part of the blockchain? Yes. How can we track it is, we can see, okay, who is the previous owner of the diamond, and now this time is the owner is really holding the diamond or not, whether the diamond was sold to multiple people, or based on your idea of that specific diamond, you can track out the details in the blockchain. Okay, so it's not only your if you put a diamond as part of the blockchain network, right now it is very limited business, right? Limited business means you want to buy a diamond, you can go maximum a shop around your location or a city around your location, right? So you cannot go back to a country or which is there in Australia. For example, you are in India, you cannot go in Australia and you cannot buy a diamond regular, right? You cannot go and buy a diamond which is there in South Africa. But as part of the blockchain network, it pushes your boundaries. Okay, so at any location based on your platform. For example, Amazon is coming up with a concept. They want to put diamonds. They want to sell diamonds as part of the blockchain network. So Amazon is a trustful platform, right? If they're implementing a blockchain, okay, they're saying that this is the previous owner, and now, and he's ready to sell the diamond, and if you are ready to buy the diamond or not, you can do a bidding in the open network. So if the bid was accepted by that seller, so basically that property will be transferred to you. So and finally it will be dispatched to you as well, right? So such communications and such data tracking, you can do it via blockchain. So basically what happens there is you are going to create a lot of trust on that specific asset by tracking the complete history of the product, at the same time based on the platform ownership, who is doing that complete control. In this case, Amazon, who is completely creating that Amazon blockchain platform, and make sure they're going to create a lot of trust among the people. Right? So this is one of the use cases. And now we will talk about how to store this data, right? How to store this data, and how this data is equally maintained in the network, and how the cryptography is working, and how the peer-to-peer communication is really working in a blockchain. Okay, so we'll explore a lot of things in this phase. So let's start with a blocks and chaining concept. Okay, so we talk about blockchain, right? How these blocks and chaining concept will come up in this mechanism. Okay, we'll talk about in detail about this. So to talk about that, I need to explain this. Okay, so before I go into this blockchain, let me explain about some of the concepts in cryptography. Okay, so there is a, in cryptography, there is a function called SHA256, a hashing function. Anyone has heard about this function? Sunil or Rajesh, maybe you can put your answers in the chat box. So do you know this function SHA256? Yes, good. So basically SHA256 is a hashing function. Okay, what does this hashing function is? You give an input value. Okay, let's give the input value is, for example, blockchain advisor. Okay, so the input value to this SHA256 function is, okay, sure. So if you give an input value to SHA256, the output value looks like this. Okay, just take output value in hash value and you print that. If you print that hash value, you know how the output looks like? The output looks like this. Understood? Anyone can understand this output value? No, right? So you cannot understand, the output will not make any sense, right? So so what does it mean is, if you give an input value to a SHA256 hashing function, basically this is called a hashing function. The output is called a hash. So this is called a cryptographic hash. I'll tell you how they create this hash value. But if you, so right now you try to understand, if you give input value to your SHA256, it is going to create an output value which is very unique and nobody cannot understand this value. Clear on this? So it means what you're trying to do is you are trying to encrypt your input value into a different value. Nobody cannot decode this value. So you can create from input value to hash function. However, you cannot create from your hash value to input value. This is not possible. Only way is you need to can create given input value. Using this input value, your hash function will calculate using some algorithms. Using that algorithm, you're going to create your output hash value. Clear on this? Now listen very carefully on this. Now you give the same hash value but small change in your input value. Now instead of blockchain advisor, you say that dot. So what you're trying to do is you're trying to change your input value. You know how the output looks like is the output will completely changes into a different value which is completely different than your previous hash value. Understood? So if you change any small input, whatever the input you're trying to give to the SHA256, if you try to change it, your output altogether, the output value will completely changes. Understood? But if you give the blockchain advisory 100 times to the same SHA256, 100 times it is going to create your output value the same way. Clear? So basically SHA256 is a hashing function which is going to encrypt your data. You cannot decrypt your data. Okay, so this is only an encryption mechanism. It is only for your encrypting your data. You cannot decrypt your data. Understood? So to decrypt your data, there is another concept. Okay, so they use a mapping concept. So using this mapping, what they'll do is, okay, for this input value, and you'll be having an output value. So what they'll do is they'll have They'll copy this value specific to this input value. What is the associated hash value? So this is your output value. Understood? This is, so they are going to map it. Okay, if they have any hash value like this, okay, this is called nothing but blockchain advisor. Understood? You understood about the SHA256? I'll tell you the real examples of some more examples of the SHA256. So far, is it clear? Okay. Now the concept is where they will use this, SHA256 exactly is mainly in banking applications. For example, there is a client. Okay, so there is a person who uses your mobile application, and he want to do some transaction, and when he's doing a transaction, that request will go to the server, right? So he is putting his username and he is putting your password. Okay, when this mobile data is going via network, okay, you consider this is all your sorry, so this is all your network. When your data is going via network, there is a possibility before reaching to the server, there is a possibility someone can hack the data. Here are they trying to tap your data, right? So in this case, when you're sending your password to your server, what they will do is they will apply SHA256 on your password. So if the password, if you apply SHA256 on your password, you'll be having a output value which is called your hash value. This hash value, you'll be sending it in the network so that nobody cannot understand this hash value. So I told you, right, you can create from input to hash value, but you cannot recreate your hash to input value. It is impossible. So what they'll do is this hash value will go to the server. So they'll say, they'll check your user ID. Okay, so specific to this ID from the server side, they will again create, they'll apply SHA256 for the password which is there in the server side. So you'll be having another hash value here, and whatever your network hash value and this hash value, they both compare. If both are equal, then server will authenticate you saying that okay, you are the right user and your password is correct, and you can process your account details. Understood? So basically SHA256 is mainly for your encryption. It is not, you're not doing any decryption here. Understood? So the decryption is something like your other side also you are trying to apply SHA256. You're going to create the hash value and you are going to compare those hash values. If both are authenticated, then your account is correct, true, or you are the right person to access your account details. Clear on this? So this is basically, this is one of the cryptographic algorithm. Okay, so cryptographic algorithm is SHA256. There are other algorithms like a SHA3, and you have RIPE MD160, okay, and KICAC256. So there are multiple algorithms. So I'll be going through those algorithms when we, when that concept comes. Okay, so little bit advanced versions of your cryptographic algorithms. Okay, so the only thing is you need to pass your input value properly to this one. So in another advantage, interesting advantage is, if you observe, the input value is in this case 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, close to around 15 bytes of data, right? You send input as 15 bytes of data, but you see the output value of hash value, the length of this hash value is close to 20 bytes of data. Understood, right? So you give the input value in 15 bytes, but you are getting output value in 20 bytes. At the same time, you give the input value of close to 1000 bytes. They give the input value 1000 bytes. you can still it accepts it, but still the output is 20 bytes. You give the input value as 1 GB, still your output value is 20 bytes. Understood? So you give how much of the value you want to encrypt it. SHA-256 can easily create a unique value for your input value. Understood? So 4 points we have discussed. Okay, SHA-256 is basically it will going to encrypt your data in a very unique way, and you give however you give it how much of large amount of data you give it, it is going to, and the output is always the fixed size, and the range of SHA-256, you are creating a hash values, right? The output of you're getting so many hash values. This is one hash value, this is another hash value. So these hash values, it means, what does it mean is it will take 2 power 256 combination of hash values it has internally support. Okay, means SHA-256 can generate maximum of 2 power 256 hash values of like this. So for this input value, it will pick one of the 2 power 256 values and it is assigned to it like this. Understood? So if that is the reason, if you can create input to output value, from output to input value, it means that your computer, if you are trying to hack, if you want to regenerate, I told you, right, if you are sending a hash value over the network in a banking network, if somebody want to tap that hash value, right, if somebody trying to reach the hash value and he want to find out what is the password for that, he need to find out 2 power 256 combinations. He need to check it for to generate a hash value or to generate a input value of your hash, in this case the real password which is in digits. Understood, right? Which is really impossible in a very short period of time when the authentication is happening over the network. Clear on this? Even the supercomputers right now we have it, it is impossible to crack the input value from your hash value. Okay, the hash value is one of the hash value of 2 power 256 values. Okay, so to find out a specific hash value out of all these ranges is very tough, even with your supercomputers as well. Clear on this concept? Please let me know any questions on this. Rajesh and Sunil. So I can mute. Rajesh, you can hear my voice? You can hear me? Please put your answers. You can understood, right? Okay. Concept is clear, right? Okay. Let me know any questions on this. Okay, great. So because the reason is there is a interlinking concept with this cryptography. That's the reason I'm asking it here. Okay, now why I explained all these things right now. Now the concept is in blockchain, I told you it's all about transactions. Okay, in blockchain. So let me draw that complete diagram. So let's consider this is a blockchain network. Understood? This is a Bitcoin blockchain network. In this network, you have a peer 1, you have a peer 2, you have a 3, 4, so on. So all this, you have the peers which are part of your network, right? So this peer will communicate this peer will communicate with this peer. At the same time, in this network, you have a miners as well. You have a miner 1, you have a miner 2, right? You have a miner 3. So what happens is, let's assume this network contains some P X number of peers are there. X equal to 1, 2, 3, so on, like that. Okay. So at the same time, there are some Y number of minors are there in the network. Y is equal to 1, 2, 3, 4, so on, like that, right? So when these peers start communicating each other, what happens is they'll have a transactions, right? So when peers communicate with each other, you'll be creating the transactions. Let's consider there are k number of transactions are created by x number of peers in the network. So k is equal to also 1, 2, 3, 4, so on. So what happens is when peers start communicating each other, they will end up in transactions. Okay, these transactions will be validated by miners. So what happens is in this blockchain network, complete network, along with this peers, miners, you will be having a transactions which are generated from the peers. These transactions, they will copy into a memory pool. Who will copy it? The network software itself only will copy it. So you will be having a mining software, right? I told you, right? The mining software. So what it will do is, what are the transactions happening in the network? So the mining software will pull all the transactions and they'll kept all the transactions in a memory pool. So all your transactions is in a memory pool. Now what these miners will do is, he will go to this transaction pool and he will pick one by one transaction randomly, not in a regularly, I mean in a sequence, not in a sequential order. It is in a unorganized way. Okay, in an unorganized way, these miners will go and pick the transactions and he will create a block. Okay, he will create a block. This block internally contains transactions. Okay, so what this guy will do is, he'll go and pick, for example, he want to pick a transaction T3 and another transaction TX50 and another transaction TX30. Understood? He pick a random transactions, and what they will do is, they'll pick these transactions and he will apply SHA256 onto these transactions. So what he will get is, if you apply SHA256, you will be getting your output value as your hash value, and the output of this SHA256, which is called a hash, which is called a block hash. Okay, they're going to create a block hash and they're going to record that block hash in a specific data structure. This is completely a data structure which we call it as block data structure. Understood? This is in simple words, it is called a simple block. Okay, block which is going to hold your data. So who is creating this block? Basically the miners are creating this block. So miners job is, go to the transaction pool, pick the transactions, create a SHA256, apply SHA256 on your transactions and create a block hash value. Along with that, which miner has created this block, timestamp information, and you will be having a block number. All these numbers will attribute, and finally he is going to create a block 1. At the same time, there is another miner will do the same job and he will create another block 2, 3, 4, so on, like that. It's keep growing in the network. So the point here is, when the other miners are creating this block, what they'll do is, when they create this block, they'll see what is my previous block information. They're going to link the second block and the first block by using your block hash value, because the block hash value of the first block is already created. The second block, they will create the second block hash value, right? And now he is going to link both block 1 and block 2 by using a parameter called a previous block hash value. What does it previous block hash value is? Nothing but the hash value of the first block he is going to store here, and using this pointer, they're both are very tightly coupled each other. This is a block 1, this is a block 2. Now both blocks are tightly coupled each other by using your previous block hash value. Understood? So now anybody has created a block 3, so you need to see what is the block hash value of the 2, and he is going to create this field name is called previous block hash value. In this specific field, you are going to store your second block hash value. So it means there is a link created between the second and third. The same way with all the blocks growing in the network, these linkage of blocks will happen. So if you see here, if you understand here, the blocks are chained together. The blocks is chained together is nothing but, this block is chained to the other block, very tightly coupled each other using your previous hash. Understood? So go through this diagram very carefully. You will be having index 0, timestamp information, hash of a block. Hash of a block is nothing but you're going to create apply SHA256 on top of your transactions, and you're going to create your hash value. The previous hash value, you're going to point out to the previous block hash value. So far, is it clear why your the blocks are chained together? His reason is whatever the block which contains group of transactions which are tightly coupled each other by using this concept of linking the hash between the blocks. Okay, I'll tell you why they are doing this. Okay, if you understand the simple concept here, I explained before this. Okay, so previously I explained about this concept, right? SHA256, if you change any transaction details, for example, a hacker comes, okay, this database, whatever we created, right? So this is created by the miners, okay? So this database, the miners who created it, right? So this database will be accessible to all peers in the network, but nobody cannot edit this database. That's what we understood, right? In the previous class. In the previous class, it is immutable concept. Blockchain is immutable in nature. How you are going to get immutable in nature? You cannot edit your transaction. You cannot delete your transaction. The reason is, okay, you have this database which is tightly coupled each other. So now I told previously, your block hash value is generated by using your transactions of a specific block. By if a hacker comes and if you try to change a transaction here, if it instead of, for example, there is a transaction happened between a P1 and P2 of worth of close to value of close to 10 bitcoins. Now a hacker comes and he changes from 10 to 5 bitcoins. He changed it, for example. So what happens is this changes, your hash value changes. If this hash value changes, the link between these two blocks will break, because this is pointing out to the previous block. Now this value is changed. Now it will point to some other block in the map. Understood? So these chains, if any hacker tried to do any change in the database of his local system, your database is getting corrupted. Understood? The link between these blocks is lost. If this is lost, and if this hacker trying to push this data into the network, other people in the network will say that my database is completely different than your database. Understood, right? Your consensus mechanism is going to come into picture here. So it makes sure that the integrity of your data is maintained in the network. Everybody has to maintain the right copy of your database in the network. Clear on this concept? Any questions? Okay.